A very good morning to all. All right, girls. You must be thinking, what has the teacher kept here? Why flowers in the maths period, isn't it? Let the day be bright and beautiful, right? The nature is so beautiful. God has created so many wonderful things that we appreciate always, isn't it? Now, let's come to mathematics. Can you guess why have I shown you this flower? Look at this. Look at the beauty of nature. Look at this. Look at this. Wonderful, isn't it, children? Now, if you observe the flower carefully, do you notice one thing? God has made it so identical. Even if you cut it into two equal parts, right and the left, this way or this way, do you think it will be the same? Yes, it will be the same. So that is called as symmetrical. That the flower is symmetrical. Alright, now look at this flower. Just a minute. Look at this flower. Yes. Yes, look at it. Wonderful, isn't it? So God is so imaginative, so creative. Now look at this flower. Do you think it is symmetrical? Yes. If we cut it into two parts, two equal parts, either this way or this way, it will be identical. So we call it as symmetrical. Alright, do not forget. We call it as symmetrical. Observe it, the beauty of the flower, children. Everything is so symmetrical, so planned. Now, not only that, look at this. Just a minute. Yes, our own money plant. Look at it. Look at the leaves. Look at the leaves. I think this will be more clear to you, children. Now, look at this. It's quite triangular in shape, isn't it? If I fold this leaf from the margin, you will notice that the right and the left overlaps. Do you think it is overlapping? It is overlapping, right? So we say that the right and the left, they are identical. They are symmetrical. Symmetrical along this line. Along this line. But if I fold it this way, then do you think it is symmetrical? No. You will notice that this shape is different and this one is different. So that way it is not at all symmetrical. But if we fold it like this, it becomes symmetrical, right? Identical. So this is the line along which our money plant, the leaf of this money plant is symmetrical. So this line that we get, that is called as the lines of symmetry or axis of symmetry. Alright, lines of symmetry or axis of symmetry. I hope it's clear to you, children. Let's continue. Now, look at this. What is this? Yes, you are right. Now don't be tempted to eat it. Okay, this is guava. Yes. Now, if you look at this guava, if I cut it vertically like this, now, do you notice the right and the left, they are identical. Do you notice that? They are identical. So we say they are symmetrical. Alright? And the line along which I have cut, that is called as the lines of symmetry. What is it called as? Lines of symmetry. Alright? Now, look at this. Wow. Beautiful. Nature is definitely beautiful. Observe the beauty in each and everything made by God, children. Now look at this. This is tomato. Yes. Now, if we cut this tomato, let me first take this part off. Alright. If we cut this tomato, not like this. This time we are going to cut it this way. Horizontal. If you cut it like this, then do you notice the right and the left, are they identical? Are they identical? It looks like, isn't it? But if we cut it vertical, they will be 110% identical. They will be symmetrical. Am I right? Now, look at this orange. Do you think it is symmetrical? Will it be symmetrical? Yes. If you cut it into two equal parts, it will be symmetrical. But if you cut it horizontally like this, then it is not going to be symmetrical. Why the pieces will be different, beta? Just check. Just check. Just a minute. I'll just take one piece of it and then I'll show it to you. Just a minute. Not the whole thing. Now look at this. Now this is our orange. Okay. Now if you cut like this into two equal parts, you will notice the right and the left, they are identical. It means they are symmetrical. But beta, if I cut it this way, do you think it will be identical? Do you think it will be identical if you take a single piece of this? Let's take a single piece. Why to waste the whole thing, isn't it? Let's take a single piece. If you cut it this way from the center, just observe carefully. If you cut it from the center like this, now this is symmetrical, isn't it? And if you cut it, let's take another piece now. Let the concept be clear. If you cut it like this, now then also you will notice that this part and this part, they are symmetrical, identical. Alright. But look at this. What is this? The teacher has brought the whole kitchen, isn't it? This is radish. Yes. If you cut it along this way, it will be identical. It means if I cut it horizontal, because I'm holding it this way, so this will be horizontal beta for me. So it will be identical. But if I cut it this way, then do you think they're identical? No. Then this is called as asymmetrical. What do you call it? Asymmetrical. Remember, what is it called as? Asymmetrical. Okay. Now, let's move on to our concepts. Alright. Observe the shape of this paper. It is rectangular in shape, isn't it? Now, if I fold this paper into two equal halves lengthwise, like this, into two equal halves, let's make this sharp crease so that it's easy for you to understand. Now, do you think they are exactly the same? Do you think they're exactly the same? Yes. So we say that as they are symmetrical along the line of axis. Which is the line of axis? Do you see this crease here made here? The line that is made here? This is called as the axis of symmetry or the line of symmetry. Now look at this. If you fold this paper this way, like this, now do you notice? Along the breadth also it is identical. It is symmetrical. And this is the line of axis. Or the line of symmetry, not line of axis, sorry. Axis of symmetry or line of symmetry. Alright. But if I fold it along the diagonals, you know what are diagonals? These opposite points, when they are joined together, it is called as a diagonal. Alright. If we fold it along the lines of the diagonal, let's observe it carefully. Observe it carefully. Do you notice? Are they identical? Are they symmetrical? No, they are not symmetrical. So, in case of a rectangle, we have only two lines of symmetry. One is vertical and one is horizontal. Alright, now let's take another figure. What's the shape here? This is a square. Am I right? Now fold it. Yes, because side in a square all sides are equal. So it is exactly symmetrical. So this is your one line of symmetry. Am I right? This is your one line of symmetry. Now fold it the other way. Fold it the other way. This is again it is identical, it is symmetrical. So this is the second line of symmetry. Don't you think? Now let's fold it along the axis. Along the diagonals. Along the diagonals. Now look. Is it the same? Everywhere it is the same, isn't it? So that is the next line of symmetry. Now let's fold it along the other diagonal. A square has two diagonals. Rectangle has two diagonals. Remember that. So let me arrange it properly. Yes, again this is symmetrical. Observe, it is symmetrical. So how many axes of symmetry did you notice here, beta? How many axes of symmetry? Look here, carefully you please observe. This was the first axis of symmetry. Am I right? This is the second axis of symmetry. This is the third axis of symmetry. And this one is the fourth axis of symmetry. So total we have 4 axes of symmetry in a square. Now let's take up the circle. Now it's the same from everywhere, right? So look at this. It is symmetrical, right? One axis of symmetry. It is again symmetrical. See? Second axis of symmetry. Now let's fold it this way. Third axis of symmetry. Let's fold it this way. So you will get indefinite number of lines of symmetry here. Are you noticing it? Are you noticing it? Let's draw the line so that it's clear to you. Look here. 1, the right and the left will be the same. 2, top and bottom will be the same. Keep moving it. This side same. Again same. So you can have indefinite number of lines of symmetry. Are you getting it? I hope it's clear to you children. So observe the things around you. Find out which things are identical, which things are symmetrical and which are asymmetrical. Look at this slice of bread. Do you think it is symmetrical? Do you think it is symmetrical? If I cut it along this line, this will be symmetrical, right? But if I cut it along this line, do you think the right and the left will be the same? No, because see, there is a dent here. So it's not going to be the same. But if I cut it like this, the top and the bottom, they will be the same. So this is symmetrical. Now, look at this bottle here. Look at this bottle here. If I cut this bottle right from the center, now observe the two sides of the ruler, beta. Are you noticing the right and the left? They are identical. They are symmetrical. And this line will be called as the lines of symmetry. But if I cut it like this, then do you think it will be symmetrical? Will it be symmetrical? No, it's not going to be symmetrical at all. So I hope the concept is clear. Even on your dresses, beta, you will see different patterns. Now, for example, look at this pattern here on this cover. Look at this figure. Look at this figure. If I keep my ruler right in the center, horizontally like this, do you notice the right and the left? Not the right and the left, sorry. The top and the bottom, they are symmetrical. Are you noticing it? But if I keep my ruler this way, then do you think the right and the left will be symmetrical? No. So this is how you are going to check whether the given object is symmetrical or asymmetrical. Alright? So I hope the lesson is clear to you. So thank you and have a wonderful day.